Right, so this is the problem number 4. That's where we stopped with our N4 examples on integration. So here in N4 we have to simplify first, but even if it was any level for this type of problem, it is definitely not in standard form. It doesn't look like anything from the table. Okay, your table, your integration table, you know you must have k x to the power n, where n is not equal to -1, and if you have this, then it will be kx to the power n plus 1 all over n plus 1 plus c. That's the only one we're going to be using most of the time when you have x, and then when you have kx to the power n and your n is equal to -1, then what do you do in a situation like this here? So if I have k x to the power -1, I did explain that to you all. In a case where it is -1, you cannot use this formula because you're going to have -1 plus 1, which is 0 in the denominator, which is undefined. So what do you do in a situation like this? You always convert it to a fraction. Okay, so this fraction is in the form f prime x on the top, f of x in the bottom. The numerator is 1. Where did that 1 come from? It's actually the derivative of the denominator. So the first derivative of x here is 1. So in this situation, the answer will always be natural log or ln absolute value of the denominator plus c. Let's see what happens here now. So here, we have to obviously simplify. We need to square this whole thing. So if I want to square this, then I will just use the formula for a plus b all squared, which is equal to a squared plus 2ab plus b squared. So here it's going to be a squared plus 2ab plus b squared, all divided by x. I'm integrating with respect to x, the dx, there's my dx here, means integrate with respect to x. So now, square root of x all squared is just x. Here I'm multiplying 2 times 2 is 4. I'm multiplying x to the power half times x. That will be x to the power 3 over 2 plus 2x all squared. That will be 4x squared, all divided by x. Alright, so now, although we squared it, there is still no formula to integrate as it stands there. We have to simplify further. We have a common denominator there of x. We can split this up into, let's count how many, 1, 2, 3 fractions. So therefore, this will be x over x plus 4x to the power 3 over 2 over x plus 4x squared over x. So all I'm doing is simplifying. I'm separating them into fractions. Okay. Why am I doing this? I want to get it into standard form. So x over x here is 1. Here, this will just be 4. And here I am dividing. So I'm dividing, and the bases are the same. So I'll write down my base once and use my exponent law, top minus bottom. So 3 over 2 minus 1 is just 1 over 2. Here, 4x squared divided by x, same exponent law. That's going to be 2 minus 1, which is 1. Now, finally, all terms have been separated. There's no multiplication, no division. So now, term 1, term 2, term 3, it's all the first formula. We're not going to be using this one here. So I'll integrate 1. When I integrate 1, what do I get? You think of What did you differentiate to give you an answer of 1? Okay, I differentiated x and I got 1. That means when I integrate 1, I must get x. Integrate here, that will be 4x half plus 1. It's going to be n plus 1. Half plus 1 is going to be 3 over 2, all divided by 3 over 2. Whatever you get here, you copy it in the denominator. Here we got plus 4x, that's a 1. 1 plus 1 will be 2 over 2, and then we got plus c. Always put down plus c at the end, otherwise you will lose half a mark there. You don't get a mark for putting down plus c, but if you leave it out, you will lose half a mark. Okay, so now I've got my x plus, I can simplify this. You must not leave 4 divided by 3 over 2. You can use your calculator. That's going to be 8 over 3, and x to the power 3 over 2 is the square root of x cubed, plus 4 divided by 2 is 2x squared, plus c. And that was the one that we left out, number 4. Let's deal with the next one now. Alright, so our next one. Also, it's not in standard form. You're not allowed to go and integrate x on the top, integrate x on the bottom separately. Right, it doesn't work like that. You need to simplify first, get it into a standard form like how we did here, and then you can integrate. So, here for this example, if you had just x minus x squared there, if it was this type of example, then you could separate it because there's only one term in the denominator. Or even if you had minus 3, I could divide everything by minus 3. But the problem is we got two terms, minus x squared minus 3, so that method will fail here. It doesn't work. So what do? We now need to look carefully and think now, how can I simplify this? So, if you had an example, let me give you a hint here. So there's a hint of another example. Let's say if you had an example like x squared, let's go for plus 6x plus 8 all over x plus 2. A simpler example. What do you notice here? What do you notice about the numerator? What type of problem is this? What type of factorization do you need to do then? This is a quadratic trinomial. Can it be factorized? You will not get something that cannot be factorized. So let's open up our brackets. So what are the factors of 8? It's either 8 and 1. 8 times 1 is 8. 4 times 2 is 8. Which one are we using? 4 and 2. So that will be x plus 4, x plus 2. Because 4 plus 2 is 6. 4 times 2 is 8. And what was the whole idea to factorize? So now x plus 2 and x plus 2 will cancel now. Can you all say that? So therefore, you end up with just x plus 4. And now we can integrate x to the power 1, which is x squared over 2. Integrate 4, that will be 4x plus c. So that is what we need to apply in order to work out this example. Okay, so now if you go back to our N3, we've done many examples before when we were in N3. How can we factorize this one here? So now, remember, there's two. You can do it in one step, or you got x to the power 4, which is the same as x squared all squared. Okay, so the whole idea here is to get the square. And what you can do is you can let x squared equal to k, although it's unnecessary, but it's a technique for you to use if you have a problem with the factorization. So what will happen there? I will have x squared all squared plus 5x squared plus 6. So if I want to use a substitution, I will replace x squared with k. So it becomes k squared plus 5k plus 6, which is simplified to a simple quadratic trinomial. And then I can factorize this. This will be k plus, what are the factors here of 6? Are we using 6 times 1? This you must be 100%. Within 2 seconds you should know the factors of 6. It's either 6 times 1 or 2 times 3. Which one are we using? We cannot use 6 times 1 because 6 plus 1 is 7. Look at the middle term. Middle term is not 7. You should know that. 2 plus 3 is 5. 2 times 3 is 6. Straight. And that is your factors. Now you could have done it that way and then substitute back, or you don't have to do it that way. All you do is open up your brackets there, and x to the power of 4 is the same as x squared times x squared. Your k times k there. Right. And then your 6 is, that's 2 times 3. Now it does not cancel, because the bottom is minus x squared minus 3. But we've done many examples with the negative when we were in N3. So what do? You take out negative 1 as a common factor, so you are left with x squared plus 3. Now double check, negative 1 times x squared is negative x squared. Minus 1 times a positive 3 is minus 3. So now x squared plus 3 and x squared plus 3 will cancel it. So what do we have now? We have basically minus 1 multiplied by x squared plus 2. Because you have a 1 in front, 1 divided by minus 1 is minus 1. So you could, you could leave it, you could do it like this. Minus, leave your bracket there and integrate. 2 plus 1 is 3 over 3. Integrate 2x plus c. If you want to multiply the negative inside, you could have done it before or after, it doesn't make a difference. The fact is, if you got that constant, you don't have to multiply the constant inside. You can keep it outside and leave it like this here. Alright, so that was this example. Let's get ready for the next one. Our next example, number 6. So here we got cos squared of 2x divided by 1 plus sine 2x. What can we do now? Right, because definitely this is not in standard form. So we need to simplify. So the hint is these examples that we've just did now. So with cos squared 2x, now when you have a square, you should think square identities. Okay, so your square identity sine squared kx plus cos squared kx is equal to 1. There we have cos squared kx. So if I make cos squared kx the subject of the formula, cos squared kx is the same as 1 minus sine squared kx. Let's see what happens now. Let's change it. So cos squared 2x is the same as 1 minus sine squared 2x, all divided by 1 plus sine 2x. We're integrating with respect to x. Now, we still got a problem now because there's 2 terms on the top. There's only terms. We cannot cancel any term there. So what do? Now, the clue is the denominator. Look at the denominator, 1 plus sine 2x. Now, if sine 2x was equal to, let's say, y. Right, so if you cannot see what I'm talking about, the clue now, then let's replace the trig function with just a variable y. Then what will happen now? You'll end up with 1 minus y squared all over 1 plus y. Now, it should be coming to you that this is the difference of two squares, because 1 minus y squared is the same as 1 squared minus y squared all over 1 plus y, and the difference of two squares, that will be 1 minus y, 1 plus y, all divided by 1 plus y. What happens? It will cancel and you end up with 1 minus y. So that's exactly what we need to do here. We need to factorize and then it will cancel. So you have an option. It's either you want to use a substitution, or once you know your work 100%, then you don't need to use a substitution. Only once you know it 100%, you understand? Otherwise, don't take a chance. Use a substitution. The substitution will assist you. Alright, so now you will factorize. That will be a minus b, 1 minus y. That will be 1 minus sine 2x, and then 1 plus sine 2x. What happens? We are at this stage here. You can see that. So then 1 plus sine 2x and 1 plus sine 2x will cancel. You end up with just 1 minus sine 2x. And now we integrate. Integrate 1, what do you get? X. Integrate sine, what do you get? You get minus cos 2x, all divided by 2, and put down your plus c there. So that will be x, negative, negative, that will be positive, 1 over 2 cos 2x plus c. Alright, so we had to know our square identity here, and then after that it had nothing to do with trigonometry. After that, it was just that one problem. Just the first step was trigonometry here, square identity. Then you had to think, how can I simplify using factorization most of the time. That's how it is in N4. Alright, so our next example, again dealing with trigonometry. So if you compare, this numerator was cos squared. This is not cos squared, it's cos of 2x. So now, when you see the number 2, you should think double angle. Okay, so now your double angle formulas. How many formulas are there for cos 2x? There's 3. Right, so cos 2x is the same as cos squared minus sine squared. It's the same as 1 minus 2 sine squared, and it's the same as 2 cos squared minus 1. So now, every example is different, so we use a different formula for our specific exam. It all depends which one will work faster than the other two. Okay, so let me just rephrase. All 3 formulas will work. However, one of those will get you to the solution quicker than the other 2. It depends on the question. So now, in this case, what do we want? We want our denominator to cancel here, because look at what happened here. This is not in standard form. So which formula can we use that will enable us to maybe do another step and then eventually cancel that denominator? That's what we want. So this denominator has both cos and sine in it. This formula only has cos in it. This formula only has sine in it. But the first one has both cos and sine. So what can we do? We can write cos 2x as cos squared minus sine squared, all divided by cos x plus sine x. And now you should be able to work it out mentally. Now you can see that the numerator is now the difference of 2 squares. The difference of two squares is what we just worked out here now. It's what we just worked out there also. And if you forgot, it's a squared minus b squared, which can be factorized. The factors are a minus b, a plus b. Straightforward. So that's a minus b, a plus b, all divided by cos x plus sin x. So I will factorize the numerator. That will be cos x minus sin x, cos x plus sin x. And now we can see that cos plus sine and cos plus sine will cancel. So what remains is just cos x minus sin x. And now you go straight to your standard table of integration. Integrate cos, you're left with positive sine. Integrate sine, it's negative cos. Plus c, so that will become sin x plus cos x plus c. So the main thing was double angle formula. After that, it has nothing to do with trigonometry. It's all about simplifying using factorization. So you can say factorization, that's one of the foundations of what we're dealing with here. Alright, so now we've dealt with a few examples previously. Still doing more examples. Now we're adding on a new concept. What happens when you have values to substitute the definite integral? Right, so here we're going to integrate, and then we have values like this value here b is called your upper limit to substitute, and the value a will be called the lower limit. Okay, this is building up towards calculating area, which is what we're going to do in the next lesson. Right, we're going to sketch the graph, we're going to calculate area, and we're going to have values to substitute. So for now, all you're doing is integrating, learning how to substitute the values. Alright, so what do you do in a situation where you have values? Let's take an example like x to the power 1 between 2 and 1. So integrate x between the limits 2 and 1. So how do you do this? Now f of x in this case is x. Now g of x, now don't get confused. Now g of x means what you integrated f of x, whatever it was, and g of x is your answer. So when you integrate x to the power 1, you're going to get 1 plus 1, which is 2 over 2. And normally you have your plus c. Remember that? Now we have these values to substitute. So I'm going to put my upper limit there, lower limit here. So there's it here. I got my answer there, I got my upper limit, lower limit. What do you do? All you're going to do is take your upper limits, so substitute into this whole thing here. So that will be 2 squared over 2 plus c, close your brackets. So this is where I am now. Let me just do it like this here. Sorry, let me just close it there, open it there. Right, so I'm closing there. Put a minus sign. Okay, now go back and this time substitute the lower limit, which is 1. So this time you're going to put 1. So that's 1 squared over 2 plus c. So what happens now? 2 squared is 4. Divide by 2 is 2 plus c minus 1 over 2 plus c. So therefore, I got 2 plus c, remove the brackets, minus half, minus c. What do you notice about c now? Plus c minus c is 0. So I'm only left with 2 minus half. So 2 minus half is actually 1 and a half. Right. So, what do you notice now? Here, I didn't write down plus c. Can you see that? Because it is unnecessary to write down plus c, because c, you'll always have a plus c, minus c. It's just extra work to go and write it down. Unnecessary, it will always be a 0. So when you have values to substitute, it is unnecessary to write down plus c. But if you want to write it down, it's fine. So what you're going to do now is, let's take the simple one, integrate. You need your calculator. We're going to substitute values, and we're going to do more examples. Let's integrate this one, number 1 here. So we're integrating, that's x to the power minus 4 over 3. So here we will just introduce brackets. There's your upper limit, lower limit. So now all you're going to do is, you got your x minus 4 over 3 plus 1 is going to be minus 1 over 3 all divided by minus 1 over 3. You got that? Right, so you don't have to go and simplify here, but if you want to, you can. But this fraction here is the same as minus 3. You're clear with that? 1 divided by minus 1 over 3 is minus 3. X to the power minus 1 over 3. Then I got my 8 and 1. So now what am I going to do? I'm going to substitute the upper limit, so that's minus 3 times 8 to the power minus 1 over 3. I'm replacing x with my upper limit, which is 8. Then I will put down a minus sign, and then I will go back and now replace x with 1. So therefore that will be minus 3 times 1 to the power minus 1 over 3. Give me an answer there. Okay, so you don't have to go and work it out individually and write it down. You've been using a calculator for years. Just do it one time. And what is the final answer you got there? Everyone gets 3 over 2. Alright, let's move on to the next one. So here, it's just that it's not x, it's t, but it represents the same type of problem. It's just that your letter is now t, not x. We are integrating with respect to t. This is not in standard form. If you remember number 4 and 5, I think we did it yesterday. We did an example like this here. This is not in standard form, so we will have to simplify it. How do we simplify? So I got my e, this is 1 over e. I can separate this into 1, 2, 3 fractions. So that will be t squared over t squared plus 2t over t squared minus 1 over t squared. It's like x squared over x squared plus 2x over x squared minus 1 over x squared. Don't get confused with the t. So now, t squared over t squared is just 1. 2t over t squared. Now, 2t over t squared is actually 2t to the power minus 1. But we must not have an exponent of negative 1. So instead of leaving it as t to the power minus 1, just leave t in the bottom. So it becomes t to the power positive 1 now. Can you see that? That's exponent laws. Minus 1 over t squared. This you have to take to the top. your exponent is not minus 1. As long as it's not minus 1, it is fine. dt, that means we're integrating with respect to t. Now, there's nothing more we need to do. This one here, if you want to, for your understanding, 2 over t is the same as 2 times 1 over t. Just like 2 over x is the same as 2 over 1 times 1 over x. Okay. Remember, why do we do this? Because we want to use the formula, this is it, where the numerator is a derivative of the denominator. Right, then the answer is always ln absolute value of the denominator plus c. So here I'm going to integrate 1. Normally if I integrate 1 and if this was dx, I'll write down x. Okay, let me just clear that up before anybody makes a mistake. If I'm integrating 1, let's look at the different things. If I integrate 1 and this is dx, that means I'm integrating with respect to x. So the answer is x plus c, because the derivative of x is 1. If I write down dp, it's just the letter that has changed. That means I won't write down x now, it'll be p plus c. If I am integrating with respect to t, that will be t plus c. Here, with respect to k, so that will be k plus c. So don't go and write down x. Although we use x 99% of the time, we're always dealing with x. And in maths, but in other subjects, there's t, there's other symbols there. So you should familiarize yourself with other letters. So this will be t, integrating 2 over t. Now 2 over t is the same as 2 times 1 over t. It's the same, if you had x, it's 2 times 1 over x. So when you're integrating 1 over x, it's ln x. So when you integrate 1 over t, it's going to be ln of t. Right. Integrating t to the power minus 2, that will be minus 1 over minus 1. You're done. You don't have to put down plus c because you know there's values to substitute. So that's going to be e and 1 over e. So this one will be long to do in one step. So let's do the e first. Substitute the e. Let's write down the full answer. Put a minus sign. And then substitute 1 over e. So let me just do that. So what I'm going to do is, I'm going to just show the substitution. I'm putting e plus 2 ln e minus e to the power minus 1 over minus 1, which can be simplified but unnecessary. So what did I do? I'm replacing t with the upper limit always first. Then I put a minus sign. Then I go back and this time replace t with 1 over e. Then you will take out your calculator and use it. We can simplify this further, but we're not going into that now. Take out your calculator and let's do this first part. Alright, so let me go and simplify as far as possible without a calculator. However, it's unnecessary for the final exam. You can just go straight and use your calculator. But just for the interest of simplification here, let's see what happens. So I have e plus 2 ln e, negative negative is positive, that's plus e to the power minus 1 is 1 over e. Here I got minus, that is 1 over e plus 2 ln 1 over e is the same as e to the power minus 1, and here negative and negative is positive. So 1 over e to the power minus 1 is the same as just e. Okay, that is dealing with fractions. Alright. This is 1 over e to the power minus 1. Let me just explain to you what happened here. 1 over e to the power minus 1 is the same as e to the power minus 1 to the power minus 1, which is minus 1 times minus 1 is plus 1. That is exponent laws. Okay, so let's go and let's see how far we can go here. So that will be e plus 2 ln e plus 1 over e minus 1 over e minus 2 ln 1 over e, because e to the power minus 1 is 1 over e. Why did I change it? It was unnecessary to do that. Or I could, oh sorry, no, it was necessary. Let me just redo. Let me just leave it as it is. So that will be 2 ln e to the power minus 1. And then I got minus e. I'm just removing the brackets, that's all. So now let's see what happens here. So let's see. If you look at this part here, this negative 1, from our log laws, okay, so let me just rewrite everything. So I have e plus 2 ln e plus 1 over e minus 1 over e, and then this minus 2 ln e to the power minus 1. So I've got minus 2 ln e to the power minus 1. I can bring down my exponent. If you have an exponent, log laws, you can bring it down, you can take it back up. So what happens is negative and negative becomes a positive, so that becomes plus 2 ln e minus e. Right. Now, what happens? We got e minus e, that's out. We got 1 over e minus 1 over e, that's. So all we're left with is 2 ln e plus 2 ln e, which is equal to 4 ln e. You got 2 plus 2 of the same thing, it's equal to 4. So from here, I'm not sure if you remember from N3 log laws, ln e is equal to 1. So therefore 4 times 1 is equal to 4. Did anyone get that answer? 4? Got it? 3.886. I have to double check my answer now. Hold it. Yeah, so 4 is the correct answer without using a calculator. If you used a calculator and rounded off here, rounded off there, then your answer should be 3,99, whatever it is, very close to 4. It's an acceptable answer. Okay, it's just that this is without rounding off anything. So here we have to integrate cos. So when you integrate cos, this is a straightforward, it's just 2 theta, so it's in the form of cos bx. So when you integrate cos, it's just going to be sine bx all over b plus c. Right, you got that on your table. So you're going to integrate cos of 2 theta. That's going to be sine 2 theta all over 2. We're not putting down plus c here because we got values to substitute. So we got pi over 4 and 0. Now, as it is, we got pi over 4 and 0. So if we substitute as it stands there, so that I got my 1 over 2, there's my 1 over 2 here. Sine of 2 times pi over 4. Close your bracket there. Now, you put down a minus sign. And now we substitute the lower limits. So that's going to be half sine of 2 times 0. Now, you need to be careful because this is pi, and pi is in radians here. So your calculator must be in radians. So what you're going to do is you're going to go to mode on your calculator, and then you're going to change it to radians. You see degrees, radians, one of the options there. So it's RAD for radians. Did you find it? What number is it? Number 4 on most of the calculators. Okay. So now you clear your calculator and you should see it's no more the small d showing up there. It's R for radians. Okay, so now you can go and type this out on the calculator, and you should get half here and 0 there. So therefore your answer is just half. Alright. So when your angle is in radians, the calculator must be in radians. If your angle is in degrees, then your calculator must be in degrees. So pi can be changed, or pi in degrees is 180. So if your calculator stayed in degrees, then that means you have to change this. You won't write down pi there, you will write down 180. But that is not a good option to use. Okay, it's best to go with radians. So the calculator does the conversion for you. You don't have to go and start changing anything here. You understand? You just go one time, mode, radians, and let the calculator do the conversion for you. Right, let's deal with the next one. We only got about 2 minutes left here. Integrate sine. When you integrate sine, so there's a here. When I integrate sine of bx, it's going to be minus cos bx all over b plus c. So I'm going to integrate sine of theta. That's going to be minus cos theta. The coefficient there is just 1. So it's unnecessary to write it down. Integrate cos. There's the formula for cos. It's a positive sine. Substituting pi over 2 and 0. So now that's going to be minus cos pi over 2 plus sine pi over 2. That is our upper limits. Minus, we will substitute the lower limit, which is 0. And there's sine of 0. Calculator in radians because our angle is in radians. Okay. So here you should just get, that is 0. This should be 1. There should be minus 1 here if you're doing it individually, and then 1 plus 1 will give you 2. Did you get 2? Alright, so we continue next time with calculating area.